All right, for number 3, we have a 12-foot ladder. It was just standing against a vertical wall. Let's draw a picture. So we have a 12-foot ladder. So here's our wall. Here's the ladder going this way. So that's a 12-foot ladder. All right, the lower end of the ladder is being pulled away from the wall. So it's being pulled away from the wall at a rate of 2 feet per second. So if we want to call this, let's for instance, we could call it S or G for ground, whatever you want to call it here. Let's, I know the answer key, they call this X, makes sense, like the X axis, and then the Y axis. So we'll call that X and Y. So the given we have is that we know that it's being pulled away from the wall, so it's going in this direction, at dx dt is equal to 2 feet per second. All right, and how fast is the top of the ladder moving down the wall? So we are trying to find dy dt, right? At the instant it is 6 feet above the ground when y is equal to 6. Okay, now if this is equal to 6, all right, we can use Pythagorean theorem to figure out what the other side is. Now, if this is 12 and this is 6, one of the things you can think about here is that this would be a 30, 60, 90 right triangle to have one of the legs half the hypotenuse. So the other side is going to be that times, remember, it's like a 30, 60, 90 right triangle. So it's x radical 3 or 6 radical 3 for this one. But if you didn't remember it, you could always do Pythagorean theorem. 12 squared minus 6 squared is equal to x squared. And then we're going to get 144 minus 36. All right, and then we're going to get 108. And then we can just keep that as radical 108 for now. We can simplify the 108. If you have your calculator, you can type in, we'll review that real quick. Let me load up the calculator. All right, we're going to open up a calculator page here. And then we just have to type in menu, number, and then factor. And then we're going to type in our 108 and hit enter. And you can see that it's 2 2s and 3 3s. So we can pull out a set of 2s, a set of 3s, and a 3 left over when we take the square root. So we're essentially going to get that 6 radical 3. So it's like 2 squared, 3 squared, and then a 3 left over when we take the square root. So this 2 squared, one of the 2's is going to come out, 1 3 is going to come out, 1 2, 1 3, with a 3 left over, and then we're going to end up getting 6 square root of 3 for this other leg. So we can use this when we're taking our solving for our dy dt. Okay, keep in mind that this side over here doesn't have a rate. It's always 12, so the rate is 0. So when we think about our formula that we're going to need, our equation, we're going to use our x squared plus y squared is equal to 12 squared. And we can use 12 because it's always constant. It's constantly 12. It doesn't change. These two sides are changing, so we can't put numbers in here. So when we take our derivative of the equation, we're going to get 2x dx dt plus 2y dy dt is equal to 0. Now we're solving for dy dt, so we plug in. We have 2 times x, which is 6 square root of 3, dx dt, which we know, once again, I have to write it down, it's 2 from the given, plus 2y, y is 6, so 2 times 6 times dy dt, and that's equal to 0. So we multiply this together. 2 times 2 is 4, times 6 is 24 square root of 3, plus 2 times 6 is 12 dy dt. We're going to move that 24 radical 3 to the other side, so we're going to get 12 dy dt is equal to negative 24 square root of 3. And then we divide by 12, and we're going to get that dy dt is equal to negative 2 square root of 3. So we can say that the ladder, right, how fast is the ladder moving down the wall? The ladder is moving down the wall at a rate of, and then we have 2 radical 3. Keep in mind we need feet per second. All right, I'll let you guys finish this, fill that in for yourselves there. Okay, how fast is the angle of elevation changing at the same instant? Now remember, we have our triangle, okay? We have this is 12 and this is 6. So this angle of elevation is right here. That's where theta is. So we have the opposite leg and the hypotenuse leg. The hypotenuse isn't a leg, the hypotenuse. So remember our SOHCAHTOA, we're going to pick our opposite hypotenuse. We're going to do our sine function. So our equation is the sine of theta is equal to the opposite. Now the opposite is changing. So that's why over the latter hypotenuse doesn't change. It's always 12. All right. We can really think about this if you want in terms of taking the derivative as 1/12 y. So now when we take the derivative of both sides, derivative of sine is cosine theta times d theta dt is equal to 1/12 and then dy dt. Now, keep in mind, what are we trying to find for this one? We're trying to find how fast is the angle of elevation changing. So that's d theta dt at the same instant, which means we know that y, if you guys remember, is equal to, and we can figure this out, right? Y is equal to 6 if we need it. There's no y in our equation, so we don't really need that. There's also no x. There's just a theta, and it's really cosine theta. So if we go back to our formula, right, cosine of theta is equal to the adjacent leg over the hypotenuse. So it's the hypotenuse we know is 12. The adjacent leg is this leg down here, which we already knew is 6 radical 3 from Pythagorean theorem and our special right triangles. So it's 6 squared to 3 over 12, or the square root of 3 over 2, and that's cosine theta. So we're going to plug that in, square root of 3 over 2 times d theta dt is equal to 1 over 12 times dy dt, okay, which we know is the same rate. So that's 2. And then we're just going to solve. So we can multiply both sides by 2 over the square root of 3. So this gives us 1 and drops out. And we're going to multiply by this by 2 squared root of 3. We have 12. 1 over 12 times 2 times 2, so 4 over 12 is going to turn into d theta dt. 4 over 12 is really 1/3, and that square root of 3 is going to stay on the bottom. If you want to rationalize, you can multiply the top and bottom by the square root of 3. So d theta dt is going to equal the square root of 3 over 3 times 3, which is 9. And then this is going to be same thing in degrees, because it's an angle measure. All right. And actually, we're not using degrees. We're using radians, okay, in calc, unless told otherwise, radians per second. If you have a calculator, you can type. All right, number 4, Superman is in level flight 6 miles above the ground. So CHS, above the ground, he is 6 miles above the ground. His flight plan takes him directly over and past City Honor School. How fast is he flying when the distance between him and CHS is exactly 10 miles? And this distance is increasing at a rate of 40 miles per hour. So, all right, now this is not the distance. The distance between him and the school, which is this, all right, this is our distance of 10. So if we want to call this, for example, x, y, and z, z is the 10 here, all right? And we know that this distance is increasing, all right? dz dt is increasing at a rate of 40 miles per hour. We want to know how fast he's flying. That would be this distance here. That's how fast he's going. That's this side, okay? We're looking technically, we're trying to find dx dt, all right, when the distance between him and the school, which is this side, when z is equal to 10, and we already know that y is equal to 6, okay? He's flying in flight 6 miles above the ground, so this is going to stay at 6 here, okay? So same thing, if we're looking for the side lengths, we would want to use Pythagorean theorem. that's our equation, okay? X squared plus y squared is equal to z squared. And remember, we can actually plug in, we don't know what x is, that's going to change. We know its flight, though, is 6. And then the z is also going to change as he's flying. All right, so this is our equation we're going to take the derivative of. So the square root of derivative, I should say, of x squared is 2x, and then dx dt is equal to, I should say it really is equal to, but it's plus the derivative of 6 squared, which is just 0, and then we have 2z dz dt. Let's plug in. So we know it's 2, all right. X we can figure out by using Pythagorean theorem. So 10 squared minus 6 squared is equal to x squared. This is 100 minus 6 squared is 100 minus 36, which is 64. And then the square root of 64 is going to be 8. So just keep that in mind, that that's equal to 8. So 2 times 8 dx dt, which is what we're trying to find, how fast he's flying, is equal to 2 times z, which is 10, times dz dt, which is 40. So 2 times 8 is 16 dx dt. 2 times 10 times 40 is going to be, 10 times 40 is 400 times 2 is 800, and then we're dividing that by 16 to get our final answer. All right, and if you got a calculator, I don't know off the top of my head what 800 over 16 is, but it'll simplify it for us, and we get 50. Now, this is also in units, so remember that this is miles per hour, and then we would say that his speed is increasing, Superman's speed is increasing at a rate of 50 miles an hour. Make sure you write that statement for yourself here, okay? Number 5, a hot air balloon is rising straight up from a level field, is tracked by a rangefinder 500 feet from the liftoff point. Now, for our purposes, this is rising straight up and down, okay? It's not moving with the wind. There's no wind on it in terms of this question. So this 500 feet is going to be constant here, okay? Now, the angle of elevation here is going to be pi over 4. We want to know the angle is increasing at a rate of 0.14 radians per minute. We want to know how fast this is going. So keep that in mind as we go along here, okay? So what we want to do is we want to figure out what this is. We can call this y. We want to get dy dt. So we're trying to find, okay, how fast is the balloon rising, dy dt, all right, when, and what do we know once again, when theta is equal to 0.14 radians per minute, or actually theta is equal to, not 0.14, it's not a rate, pi over 4, technically radians. Okay, now the other thing we're going to need to know is we're going to need to know what this is. So if you're trying to find this, the equation that we're going to use, because we have an angle measure and 2 sides, our equation is going to be one of the SOHCAHTOA equations. Because we have the opposite and the adjacent side, we're actually going to do the tangent of theta is equal to opposite over adjacent. Now for our question, we're going to do the tangent of pi over 4 is equal to the opposite, which is y, over the adjacent, which is 500. All right, and if you remember, pi over 4 is 45 degrees. The tangent of this is sine over cosine. Sine over cosine of pi over 4 is square root of 2 over 2. So the tangent of pi over 4 should be 1, okay? And if you do trig tangent, you can do pi over 4. And this is the board interrupting here. Pi over 4, enter. There's your 1, okay? So this is 1 equals y over 500. And then we can multiply both sides by 500 to get that y is equal to 500, okay? So that's key when we take the derivative of this. So remember, this stays the same. So technically our equation is the tangent of theta is equal to the y over 500. Or we would say it's 1 over 500 times y. So we take the derivative of both sides, and you could just write it like this instead, or think about it like this as you do your derivative. All right, derivative of both sides, we're going to get tangent. Derivative of tangent, remember, is secant squared theta d theta dt is equal to 1 over 500 times dy dt. We didn't even need y because when we take a derivative, there isn't a y left over. We do know, right, that we want to find dy dt. We know that d theta dt is 0.14 radians. We're going to have to do a little bit of work for secant squared, so we technically do need this when we do this question. Now remember, secant theta is equal to the reciprocal of cosine theta, okay? So cosine is adjacent over hypotenuse. Now, if you remember your Pythagorean triples, this is a 45, 45, 90. If these are both 500, this side is 500 square root of 2. And you can do Pythagorean theorem to get that as well. All right, so it would be the secant is hypotenuse over adjacent. The hypotenuse is 500 square root of 2. The adjacent is 500. These are going to drop out to give me the square root of 2. So that is the secant theta here. Okay? So when you're doing this, we're just going to go ahead and plug in. So it's the square root of 2, secant theta, squared, times d theta dt, which is 0.14, is equal to 1 over 500 times dy dt. Okay, square root of 2 squared is just 2. So 2 times 0.14 is 0.28. And that's equal to 1 over 500 dy dt. So we can just multiply both sides by 500 to get rid of the 1 over 500. And then 500 times 0.28 is 140. And so we're going to get a final answer here of 140. And remember, this is a rate, okay? And we're doing the rate of, we're increasing. So we're going feet, okay? And then minutes. So this is feet per minute is equal to dy over dt. So the balloon, or hot air balloon, all right, is height, we can say, is increasing at a rate of 140 feet per minute. All right, and there's page 2.